informed this in my previous session that I have shared the eLab credentials with everyone. I hope you all have tried to log in and try to work on that.
Yes, ma'am.
And session, I guess you asked me to have one session on eLab, right? I actually don't
Yes.
remember, but someone asked me. So I hope you are being able to logged in and able to work on that.
Yes.
Good. Okay. Rajithan, are you saying something? So let's just wait for 5 more minutes. Okay. Let everyone join and then we will start the session. At 3:05 we will start the session. Okay.
Okay.
Ma'am, excuse me, ma'am.
Yes, Rajithan.
Uh, Ma'am, I have recently joined a job on NTA since past 2 weeks.
Congratulations.
Yeah, so usually I put the class on record, so I won't be able to give any reply.
Okay, okay, okay. No problem.
Yeah,
But
I'm in
make sure,
office. I'm in
Rajithan,
office, so I usually record and then watch recording later on.
okay, Rajithan, no problem. But make sure that even the candidates who have registered after you have completed the course. So make sure you complete it before 120 days. Okay, because once your
Okay, ma'am.
time ups, your course will be considered as incomplete. Even though your these classes will be going on, even those 120 days gets over, but you will not be able to get the certificate. Okay, this is the only problem you will
Okay,
face. So make sure you complete it before deadline.
okay, ma'am.
Okay. Okay, can anyone just remind me what we have learned till now? Actually, I'm teaching the same topic in another class as well, so I'm not being able to recall that. I think we have done the numerical, that entropy one, decision tree, right? No one remembered. Achal, do you remember what we have learned in our last class?
Ma'am, actually, I didn't attend that because I was in office. I had an urgent meeting at that time, so I didn't attend that class on Friday,
What about you, Rajnan?
on Thursday, sorry. But we like one note has been shared regarding entropy numerical only. So
It means
I
I
think
have discussed.
that is
Yes.
what we have
No,
covered till now.
yes, I just wanted to reconfirm it because then I am thinking that I have covered that numerical and I have asked you to solve the numerical. Did you guys try that?
Um,
Ashish, are you saying something?
I'm actually trying currently. I'm trying since 1 hour. Like I'm reviewing the whole recording again. I'm
Okay.
solid. I'm solid. I've got some things like okay.
Okay.
I'm working on it actually.
Okay. What about you, Shashin? Did you try to solve it?
No, ma'am.
Why, Sachin? And what about other candidates? Rajnandni, Kaushendra? Not yet tried? You tried it. So, did you find the same decision tree as I have shared with you in the Word file? Do you able to recreate that? See, understanding that numerical is, you can say, is very important to understand about that algorithm. Just give me a minute, okay?
Sure, man.
So I hope those who have not tried have understood the algorithm clearly. Because if you see, if you will try that algorithm, I think then only the steps will be more clearer. So those who have not tried it, I request you that in your next class, mean in your tomorrow's session, before that session, complete that numerical. Okay, solve it by yourself. Take notebook and pen. It will take uh, maybe 1 hour. If you are first time doing, maybe it will take 1 hour. Okay, but make sure you solve it completely. Now, let's come to its execution part, how to execute that algorithm. So, okay, before that, quickly tell me, decision tree is a supervised algorithm or unsupervised algorithm?
Supervised,
Supervised. Supervised. And what is supervised algorithm?
where labels are defined.
Where data set is labeled. Good attempt. Okay, now this we have discussed. Let me increase its size. Pruning to get an optimal decision tree. Basically, we will remove the unnecessary attributes which are not necessary. Okay, unnecessary nodes we will remove from the decision tree to get the optimal decision tree. And if means if your tree is very large, have too many branches, then your data set will be overfit to your uh, to the model. Means your data set will be overly fit. Means if you're training your data set, then you are getting uh, maybe around, let's suppose, 96 accuracy, and also in your testing you are getting a high accuracy. Okay, what is happening? Basically, your model is getting overfitted with your data set. Okay, and when you have very less features, then you will face the underfit condition. Okay, means neither in your training you will get the high accuracy, nor in your testing. Okay, so both the issues we need to avoid. Okay, so in such case, we have to have optimal decision tree. We cannot take this unnecessary nodes, or we cannot remove large amount of nodes from our data set. Okay, otherwise we will face these difficulty. Now, how to now pruning methods I'm not going to discuss in this session, as I have to, even to implement this decision tree, it will take me a large amount of time. So if you have time, if you want to know more about it, you can study more about pruning. Okay, how to get an optimal decision tree. Now, advantages, disadvantages, I hope you can study. Decision tree in real world, you can use in churn analysis, means customer churn analysis, means who are the customer who are going to left your organization. Okay, or means organization means your company. Okay, who are not going to buy any other item from your company again. Okay, sentiment analyze, if you want to do investment solution, where to invest, whether to invest or not. Okay, high customer satisfaction, all those things. If you want to make some decision or have to build some criteria, you can use decision tree. Now, this is one more example where we have the problem. We have to classify different animals based on their features using decision tree. Okay, so we have two features. One is color and another is height. Color and height are the features, and label is given. Okay, animal names are given. Now, based on this feature, if someone gave me some new data, I have to be able to I should be able to decide whether which type of animal it is, which animal it is. Okay, so what we will do first, we will find the entropy of label. Okay, then we will find the entropy of color in with respect to label. Then we will find the entropy of height with respect to label. Then we will find the information gain of both these attribute. Okay, now whose information gain is largest, we will take that as a root node. Okay, then in that root node, the node which we will take as a root node, we will take the unique values of it, and for the unique values basically what type of decision we will make. Okay, then what will be our next attribute for decision? For example, this is solved over here. You can try it out. It's a very small example. Okay, if you want to try, you can try it out. Okay, so what you have to do, firstly, for your target variable, you will check how many times giraffe is coming, how many times tiger is coming, how many times monkey is coming, and how many times elephant is coming. Based on that, you will calculate the entropy. Since we have 4 unique values, you will have this four times you have to create, like -3/8, log base 2 3/8. Okay, and so on. You will find out the entropy of the target variable, which will come out it as 0.571. Then you will calculate the entropy of every attribute, means color with respect to target attribute, then height with respect to target attribute, and a tree like this will generate. I hope I'll share the slides with you, and I expect you to solve it. Okay. Now, implementation we are going to see today. So what we have taken a loan data set where different features where of person are given. Okay, like credit policy, purpose, initial rate, installment, and at the end it is mentioned whether that person has fully repaid the loan or not. Okay, I'll show you the data set. Let me just remove all those things. This actually I was explaining in my last class. No? Okay, so this is my data set, right? Now, this data set contain these too many attributes. Okay, and this is my last, this is my labeled data set. This is my labeled column, not fully paid. Okay, here where 0 is mentioned means that person is not fully paid the loan. Okay, and where 1 is written means that person is fully paid the loan. And these features are given. Okay, now if someone give me some new data set and asked me to tell me whether to give loan to that person or not, I will decide based on that column. If the person is able to fully pay the loan back, okay, repay the loan, then I will give the loan to that person. Otherwise, I will not give, right? So this is my labeled data. This is my labeled column. Okay. Now these are the different features. Now I need to implement this. Okay, I need to create a decision tree out of this. How I can create decision tree? Okay, since just tell me when you were doing that Python libraries you were learning. So which editor you have used or which IDE you have used to run those programs, to run those commands?
Spider.
Spider.
Yeah.
Everyone use the same IDE? I hope everyone has installed Anaconda.
Yes, Anaconda is there. VS Code is there.
Okay. Now, just give me 1 minute, okay? Okay. So we are going to use the same ID which you have used before. And if anyone have not installed Anaconda, please install it. If not, then use Google Colab, okay, or any other ID to run your Python programs. Okay. Now, first step, what we are going to do, we are going to import the pandas library. Okay. And why we are importing pandas library? Can anyone tell me what is the reason why we use pandas?
Data cleaning.
Data cleaning, good. Okay. हमें data read करना है, data cleaning करनी है. Okay. We will use pandas. Okay. We are aliasing it as PD. I hope everyone knows what is this AS and why we are aliasing it as PD. See, if not, see, aliasing means if you want to use this library, every time you have to write pandas dot whatever function you are using from pandas. Okay. So to avoid that, if you want to use a short name, we are aliasing it as a short name. Okay. It's up to you how you want to alias it. If you want to use PD, you can use PD. If you want to use something else, some small word, some like P, if you want to use, you can write that as well. Okay. Now, after that, we are importing some other libraries as well. For example, we have imported sklearn library. Okay. Now from this sklearn library, you can see it's very enriched with machine learning algorithm. Okay. If you will search about it in Google, if you will type sklearn and you will search about it, you will see many supervised, unsupervised algorithms are implemented in sklearn. Okay. You can directly import from there and you can use it. You just have to give data to this already implemented algorithm. Okay, so nothing much you have to do, means those entropy, how you were calculating, you were writing the formula, you were putting the values, all those things you don't have to mention over here. Okay, you can simply write the name, you can simply write the method you are going to use and mention the data, and it will be automatically done. Okay, now this is the reason we have from sklearn importing different modules. Okay, so we have imported tree. Okay, because we are going to generate a tree. Then we are importing test train split from sklearn.model underscore selection, because we are going to split our data set into the training data set and testing data set. Okay, then we are importing decision tree classifier, because classifier will basically classify our data set. Okay, now then we have imported confusion matrix and accuracy score. Accuracy score, basically you will be able to get like how accurately your algorithm, your model is able to predict the data. Okay. And confusion matrix, we will shortly learn about it. Basically, it will give you 4 values What are those 4 values? What you can conclude from that? We will shortly look into that. Okay. For now, just focus on that. We are going to create a tree. We are going to find out the accuracy, how precisely, how accurately your model is being able to give you the correct answer. Okay, give you the output. Now let's run these libraries first. See, if you are using Spider, there are 2 ways to run. Either you can run the complete file, okay, using this play button, or you can use this button to run the selected portion, or to run the line where currently your cursor is there. Okay, so let's run this. Okay. Now, this is the area where you will get the this is console where you will get your output. Okay. About this window, I'll discuss in shortly when we will come to the variable and plots. Okay. So after running this, these libraries are successfully run. Now what we will do, we will import our data set. Okay. So to read the data set, since we are going to use pandas, we will write as pd.read_csv because the file I have is the CSV file. Okay. Now, after that, I have to give the file name. My file is loan_data.csv. Okay. Then separator. Since it's a comma separated file, I have mentioned the separator as well. Now this data set I'm storing in a data set variable. Okay. I have created a variable where I'm storing the data which I'm reading. Okay. Now tell me honestly, if I run this file, okay, if I run this command, will it get successfully executed?
It doesn't have the location on it where it is
Good.
fetching the, yeah.
Good. If I run this, it will give me error. It will say file not found error because it doesn't contain the complete location of the file. Okay. Now you have 2 methods over here. Either give the complete location over here. For example, my file is on desktop. Inside that I have a folder. Then inside that I have another folder. Then inside that I have this file. So I have to give the complete location. Another thing is Spider gives you to choose a directory from here. Okay. So you can click on this browsing a working directory. Okay. From here, go to the navigate to the folder where you have your data set present. I have my data set on my desktop folder in the classification. Then in the DT folder, I have my data set. So I have selected this file. Now if I run this, it is successfully executed. Okay, because now it is being able to read the data from my current directory. Okay. So either give the complete location over here or choose the directory from here where your data set is present. After that, now, since you have already learned some of the functions of Python, tell me what this command will give me, this println dataset.
Length of number of rows in the data set.
Very good. Let's run this. So I have 9,578 rows. Okay. Now, the next command, what will be the output? I have written dataset.head. So what it will give me?
First 5 rows.
First 5 rows. Okay, so first 5 rows. And if I want to see the last 5 rows, what command I will use?
Tail.
Good, tail command. Okay, now tell me about this as well. Okay, rest of the things since you have not learned before, so I'll explain that, but I expect you to answer for that as well. That this shape command. What will be the output if I run dataset.shape? Rows and columns. Shape of the data set. 9578 rows, comma 14 columns. Remember this number 14, okay? I'll tell you why I'm asking you to remember. Remember this number 14 it is, okay? So I have these many rows and 14 columns. Okay. Now, come to the data set again. See, whenever we are running this decision tree, okay, make sure your data is of numerical type. But see here in this column, this is numerical data or the categorical data?
Categorical.
Categorical data.
Categorical.
Good. So we have to convert this column into the numerical. There are several methods, but we are going to use one of the method, which is get dummies. Okay, I'm telling you well ahead that this method which we are going to use, it sometimes work correctly, but sometimes not. So you have to learn some other methods as well. For now, I'm just telling, since this method is quite, it takes time to understand about this method. So I'm taking this method as an example, so that you all get what we do when we are using get dummies method. But I expect you to learn other methods as well. Like we have one hot encoding to convert categorical data into numerical data, and we have other methods as well. So learn about it. Okay, we are going to use get dummies method. What we do when we use get dummies method, see, suppose I'll select this column. Okay, in this column I will if I'm using get dummies method, what it will do, it will take the unique values from this column. Unique values it will take. Okay, and what I'll do when I'm performing this, I will drop this purpose, because purpose is my attribute name that I don't require. So I will drop this first, and then I will ask, then I will apply get dummies method. What I'll do, I'll get unique values from it. So see, first value is debt consolidation, right? So what will happen, a new column of debt consolidation will be created. Okay, like this. Let me just copy this and let me just paste it over here. A new column of debt consolidation will be created. Now what will be the values fill inside it? Wherever debt consolidation is there, it will be 1, and wherever it is not there, it will be 0. Okay, like this, values will be filled. Okay, then what will happen? Another unique value will be taken. Another value is credit card. So credit card column will be created, and similarly values will be inserted. Where credit card is there, 1, where not, 0. Okay, next unique value, if you will see, it's all other. Then we have home improvement, then we have small business, then we have major purchase. Okay, like this, all unique values columns will be created, and inside the column values will be written wherever those values are present. Otherwise 0 we will insert. Okay, so these columns will be created, and then at last what we will do, we will drop this whole column, because now it is not required. The information we have used, we have created new columns from it, and there we have inserted the data. Okay, now let's see into the implementation, how we are going to implement this. Okay, so okay, just remember this. If I'm saying x is equal to 1, I'm talking about column, and if I'm saying x is equal to 0, I'm talking about row. Okay, now let's see the implementation. Let me increase its size. So what I'm doing, I am applying get dummies method, which is in pandas only. Okay, so from what we are doing, from data set, in our data set, whole data set is present. Remember, we have created a data set variable where we have read our data set and stored inside data set variable. Okay, so from data set, I'm using my purpose column. Okay, purpose column is my categorical column. If you remember, see, this is the purpose column. Okay, so I'm using this column. What I'm doing, I'm dropping the first. Okay, the first, that column name I'm dropping, and I'm storing the data inside purpose underscore C. So basically get dummies will take the unique values, will create the separate columns for them and insert the values inside it. And after that, I'm printing this purpose underscore C. Let's run this two commands. Okay, now if you want to see what is under purpose underscore C, you can go to this variable explorer, and here whatever variables you have created, since I have created this data set, and after that I have created this purpose underscore C. If you will double click on it, you will be able to see what all data set is present inside it. See, purpose underscore C contains new columns. Okay, how these new columns are created? It has taken unique values from purpose column and created new columns from it and inserted the values wherever that unique value is present. Otherwise, it has placed 0. So this matrix, this purpose underscore C gets ready. Okay. Now what we are going to do? We are going to concatenate our data set with purpose underscore C. Okay, means our data set with the new columns. So what we will write? We will write this concatenate command. Okay, we are going to concatenate our data set, comma, purpose underscore C. We will, okay, and we will drop our purpose column because it is not required now. Okay, so we will drop this purpose column and we will concatenate the remaining data set. Okay, let's run this. See, now we have another variable loan underscore f, and you will be able to see all the columns here except your purpose column. Okay. This new columns also are concatenated with your data set. Now, if you want to see the head, means top 5 rows, you can check it using head. Okay, now let's run this loan underscore f dot shape. Okay, in loan underscore f, we have our concatenated data and shape. Now, tell me what shape it will. Rows and columns will remain same or will change? If I run this shape command now, tell me whether my rows and columns will remain same or will it change? Will it get changed?
It will get changed.
Rows will change or columns will change?
Columns.
Columns will change. Good. Okay. So let's run this. See, earlier we have 9578 rows, same. But earlier we have 14 columns. Now we have 19 columns. 5 more added. How it get added? Because I have just explained the process, right? How it become from 14, how it became 19. Okay. I hope it is clear to everyone.
Yes, ma'am.
Good.
Yes, ma'am.
Okay. Now, after doing this, we are going to split our data set, okay, into the test and train set. Now, how we do that? See, what will happen? Basically, these columns will be consider it as before not fully paid. Okay. So what will happen? Let me color this up. For example, I'm dividing my data set into the train and test 70 and 30% ratio. Okay. So let's suppose the data set which you all being able to see onto the screen, and this is only this is the data set. Okay, we have. Okay. So this will be my X train. Let me color this out. Okay. And this will be my Y train. This will be X test. Oh, text I don't want to change. I want to. This mouse. And this will be Y test. Okay. So see, since I'm going to use the sklearn library to split my data set into train and test. So it will not be like the first rows it has taken as my training data set and last rows it has taken as my testing data set. It will not be like that. Okay, it will randomly select the rows. Okay, but for now, just to explain you, I'm just for the explanation purpose, I'm telling you like suppose it has selected the data set in sequence. So first, this blue color, what will be this blue color rows? These will be my X train. Okay, and this orange one will be the Y train. Mean based on this feature, I will get this output. Okay, and this will be my test set. Means I will provide these rows, this yellow one, but I will not give this green one as green one to my model. Okay, green one it has to predict. If the output it is giving, the model, the output it is giving is same as the green one, means these are my actual values, and suppose my model predicts 0 only for this row. Okay, for this as well 0 only, means my model is correctly working. If it predicts something else, means my model is not predicting the values correctly. Okay, it's not predicting the values accurately. Okay, so this is how we are going to do. See, this blue and orange are the training. This yellow and green are for the testing. Okay, so blue and orange we will provide for the training. Then yellow one we will give and will ask the value for the green one. If it will give the correct value for the green one, our model is working perfectly. If it gives the wrong value, means we still need to make some changes. Okay, now let's see how we are going to split. So what we are doing, we are giving not fully paid column. Okay, one more thing. See, I have not taken this column because see what I have to do then. I have to create all those columns and place it before not fully paid, and then I'll be able to show you. So for now, just consider this data only we have. Okay. Although this data is also this, if I'll write these columns, all those columns, data consolidation, credit card, or all other, or measure purchase, then all those column will come inside this blue with this blue one. Okay. Now, so not fully paid. Okay, just one more thing. Not only in blue color, blue and yellow ones. Okay, this data set will come under blue and yellow one. Now come again. Now, not fully paid column, I'm taking it from my loan underscore F data set. I am storing it into my Y variable. Okay, so this is basically my target variable. This Y is my target variable, not fully paid column. Okay, after that, I'm storing this loan under from what I'm doing. I'm taking the whole data set. From whole data set, I'm dropping not fully paid column, and the remaining data set I'm storing in X. Okay, so basically what I have done over here, I have taken this blue and yellow and stored in X, and I have taken this orange and green and stored in Y. Okay, consider this is the only data set I have. Then blue and yellow I have stored in X, and orange and green I have stored in Y. Not fully paid column is in Y. The remaining columns data is in X. Okay. Let's run these columns, these code. See, my when I run this Y is equals to loan underscore F not fully paid. See, what is the data set I receive here? Only not fully paid data set. Okay. Then if I run this X loan underscore F dot drop not fully paid, if I run this, I will receive this X variable where I have all the data set except not fully paid column. Okay. Now what I'm going to do, I'm going to split my data set into train and testing. Okay, X and Y I have created. Now I'm going to split that data set into train and test. So make sure you maintain this order. X train, X test, these are the variables I have created. You can change the name as well. Okay, these are not the keyword. I'm just asking you to remember the order. First, I have written X train, then X test means train value of X variable, then X test, Y train, Y test. And inside this, what I'm storing, I am using train test split method. And where I'm storing this X value, which I have, means in X, I have all the data sets except not fully paid column. That values will get splitted into X train and X test. Okay. Then I have Y variable. Okay. That data set will be splitted into Y train and Y test. Okay. Now, how much percentage I'm taking? I'm taking test side as 0.3, means 30% I'm taking it as a testing 30% I'm taking as a test for testing purpose.
Test data.
Means test data, and remaining 70% I'm taking it as a
Training
training
data.
training data set. Okay, it's up to you how you are, how much percentage you want. Means if you want 60-40 ratio or 80-20 ratio, you can do that. I'm doing 70-30 ratio. Okay, if I'm mentioning test size is 0.3, means my 0.7 is my train data. Okay, then I have mentioned random state 40, means randomly it will select the rows and place into that. Okay, so if you will even if you don't mention it, your algorithm will automatically randomly will pick up the rows. Okay, now let's run this data set. I mean this command. See, for every 4 variable, you will see a variable over here, and when you will click on this, you will see the what all rows it has picked. Okay, now our data set is split into train and testing. Now we are going to train our model, and we are going to fit our model according to our data set, and then we will find the entropy. Okay, now how we are going to do that? Firstly, we are going to use decision tree classifier. Okay, and inside that criteria we are using as entropy. That I'm storing inside CLF underscore entropy. Okay, this is the variable I have created. Inside this, I'm storing a model. My model is a decision tree classifier where criteria I have used entropy, because to solve decision tree, you have another criteria as well. Okay, I'm using entropy. So that I have stored in CLF underscore entropy. Let's run this. After this, I need to fit my model according to my data set. Okay, so what I'll basically give this blue one and orange one to my to fit into my model. Okay, this blue and orange, this X train and Y train, X train and Y train, I will give to my model. So let's come back to this code again. So X train and Y train I'm giving to my model. So I have to use the dot fit method, CLF underscore entropy dot fit X train Y train. Okay, so my model is being trained based on my data set. After that, I need to predict my test data set. Okay, so what I'll give this one, this value, where it has gone. Okay, this yellow one I will give, and I will ask my model to predict this green values. So green one, for now, these are the actual value. Whatever my model will predict will be the predicted values. Okay, so the yellow values I'm giving, but when I was training, I have given blue and orange one both. Okay, but when I'm testing, I'm giving only the yellow values, not the green values. That I'm asking my model to predict. Okay, so let's come back to this code again. So what I have done, I have created a variable prediction where I'm storing the values CLF underscore entropy dot predict X test. So I'm passing X test, that yellow matrix I'm passing. Okay, and passing to whom? CLF underscore entropy, because here my model is trained. This is my trained model. To my trained model, I'm giving this, and I'm asking it to predict. And then I'm printing the prediction. Okay, so let's run these two commands. See, so this is the prediction output. If you want to see, you can see it from here as well. To the variable explorer, you will see a prediction variable. Hopefully, okay, it's here. Okay, you can match it out with your this. No, you won't be able to match it out because you don't know what all rows it has taken for your test split. Okay, so if you want to know the accuracy, what happened? If you want to know its accuracy and confusion matrix, since today we have less time, I don't think I'll be able to discuss that. Okay, if I'll get time, I'll discuss today. Otherwise, I'll discuss it tomorrow. Okay, accuracy basically will tell you how accurately your model is predicting the output. Means if you have 0 as the outcome, whether your model is predicting 0 or not. If it is predicting something else, means your model is incorrectly predicting. Okay, so accuracy score we are checking. So how accurately it is predicting. So what we are going to pass inside this, we are going to pass y test. Okay, and the predicted value means that we are giving the green values, that from your this green values we are giving, and these are the predicted values, and this comparison will be done and accuracy score will be given. Okay, so I'm running both these commands. Confusion matrix, I'll let you know. Okay, when we will get time, maybe by tomorrow I'll tell you. Okay, so see, these four values which are coming now, these are coming from the confusion matrix, and this 0.731, this is the accuracy basically. Okay, so we are getting
73%.
73.17% as our accuracy. Okay, now after getting the accuracy, if you want to plot your decision tree. Okay, so to plot your decision tree, we are going to use the matplotlib. From matplotlib, we are going to import pyplot as PLT. Okay, this is the method for the tree text representation of your tree. Okay, so you can use this export underscore text from your tree, and there you can pass CLF underscore entropy. Your model you can pass. Okay, and then you can print your text representation. See how it will look. Basically, your decision tree text representation is given. Okay, if I increase this, see, features are given, their class is given, and several other things are given, and depth is also mentioned. And if you want to see it in a decision tree form, then you can use then you can create a figure. Okay, like plt.figure size you have to give, where width and height you will mention. Okay, here you can use that plot underscore tree method which we have imported. Basically, we have imported tree, and from tree we are using one of its method, which is plot underscore tree. Okay, there we are passing CLF underscore entropy, and we are filling it. Filling means when you will plot your tree, it will contain some value like accuracy, or if names are given. Okay, those classes names will be there, decisions names will be there. So we are making it as filled equal to true. And let me run this to commands. See, okay, I think I have not run these. Okay, this red icon shows that your command is still running. Okay, once it will turn into some other color, means your decision tree is red. Okay, means your command is successfully executed. Since it's a big data set, it will take some time. And once it is finished, your decision tree will be visible onto the plots. Okay, this plots. Now, and if you want to, okay, just give me a minute. I'm my laptop's charging is just about to gone. Okay. Once it will over, your decision tree will be visible here. Another thing, if you want to save that decision tree, if you want to save any figure which is being executed onto this plot, you can use the save figure method. Okay, and you can give the figure name over here along with the extension. Okay, and if you are not mentioning the complete location, then it will be saved onto your current directory. Okay, so if I run this command, let me run. Okay, this is my decision tree, and I want to save it onto my the same directory in my DT directory with the name loan payment.png. Okay, so let's run this. And if you will go to that directory now, you will see that I have a file, I have a figure with the same name. Okay, it will take some time. It is stored at 254 because before your class I've just run this command. Okay, once your command get executed successfully, the time and all those things will be, see, it's 349. In just now I have run this command, so this is the new figure I have. Okay, now since we have too many columns and too many unique values inside those columns, my tree is quite complex, have so many branches inside it. If you will take a small data set with less unique values, you can say, then you will find that when you run this decision tree, it will show you in these boxes. Means if you will zoom in, you will see here it will not be visible, but when you will zoom in and with a small data set, you will see all those things are mentioned. Entropy is mentioned, class is mentioned. Okay, all those things will be there.
Okay.
So what I'll do, I'll share this code dataset PPT with you. Okay, try this out, and I'll give you a new problem as well. Okay, so try that out as well. Okay, and if you face any difficulty, please let me know. Another thing is you have to learn about different methods which will help you to convert your categorical data into numerical data. And here we have not done the, we can say, the complete processing methods we have not used, because since we have not used here duplicate values, we have not checked the null values. So all those things, whenever you are taking any data set, make sure you do all those things, you check all those things first. Okay. Ashish, are you saying something?
No, just writing it.
So I'll try to give you a new problem. Okay. So whenever you try a new problem, make sure you check the null values, you check the duplicate values, and if there are any other column contain no values, just remove those as well. If you have categorical data, convert that into a numerical data. Okay. So, and what are the different methods to do that? Please check it out. And if you face any difficulty, do let me know. You can discuss in the group as well. Another thing, since many of you have joined late, so I have shared ELAB credentials with everyone. I hope you all have received ELAB credentials.
Yes, yes, received.
So try it out. Okay, log in, try to log in, and you can run your Hive. I have told you how to execute your Hive commands, right? So you can try it out. If you face any difficulty, you can discuss in group or you can discuss in class. Okay.
Okay.
Okay then. Thank. Ashish, do you have any query?
Yeah, I was checking that the e-lab. So
Yes.
how to proceed on that actually?
Just give me a minute. Let me log in first.
Yeah.
Or what I'll do now, I'll share ELAB manual as well with you. Okay,
Okay.
but just give me a minute. If I don't have those test credentials with me, I'm just trying to find it out. If I'll get it, I'll show you just now. If I'll not, then I'll share the manual with you. I have created a manual because many of you face difficulty while running those commands.
Okay, no issues. I'll test it out myself. Then if any issues, I'll ask again tomorrow.
Okay, let me see if I can find those test credential, because before if I need to tell you, I should first have those test credentials with me. Just give me 2 minutes. Let me see if I can find it out.
Okay.
No, actually, I won't be able to tell you right now because the problem is those credential will not work with my CDAC LAN connection. Okay, it have some privacy issues or something like that. So if I'll connect with my hotspot, uh, this Teams might not work because there is some connectivity issue. Okay, so what I'll do, I'll step by step tell you everything. You can try it out. Okay, first login, then there you will get a editor option. Okay, then in editor you will have this Hive option. You can go to the Hive, you can run your commands there, and if you need to upload file, for that also I'll share the steps with you. Okay, I'm sorry because of this network issue. Now some maybe what I'll do tomorrow, now I'll take class at some other place where I don't have all those network issue. Okay, in CDAC, if with CDAC LAN, if I'll try to login, it will give me some access issue. Okay, because it is allowed only on some devices. I'll try to have next day in at some other place, then I'll tell you.
Okay, no issues. Yeah.
Okay, Ashish. Okay, thank you everyone. Bye bye, take care. I
Bye-bye.
hope you all will practice and will try to find out some new methods to convert categorical data into numerical data.
Yeah, will do. Thank you.
Okay, bye bye, take care.